All right, folks, thanks for watching video one up here. And the idea of using, regression equations to fit some data, there are options, right? You could have a linear fit, or you could have a exponential fit, or a quadratic fit. And that's what math and science people do. They come up with an equation that fits their situation the best possible. That's called modeling. Now, in order to do that skill, we have to have some other kind of underlying skills, like how do you deal with logarithms, right? So it says change the logarithmic statement to an equivalent exponential statement. It's just using the definition. It's sometimes, in these kind of problems, you're not really doing much other than just using the definition. So here's the base, here's the exponent. Okay, so let me make a couple notes here. The a is the base, all right? The 8 is the exponent, and the 5 is the number that we're going to get. This is the number that we're going to get after we raise the base to the exponent. So we're going to do something like this. We're going to say a to the 8th power is equal to 5. All right, that's all you got to do on those problems. Now, this one looks a little funny, doesn't it? I don't know how much we have talked about E. It doesn't feel like we've talked about E very much. And E is defined, you might say, what is he saying, E? E, the letter E, has a numerical definition in mathematics. And so let's jump over to Desmos real quick. If you don't have the Desmos file open that I attached on the first video, or in the first bit of our Google Classroom assignment, open up Desmos real quick. And I want you to notice when you type the letter E, what happens? 2.718. See, it's kind of like pi. It's an irrational number. It has meaning in mathematics just like pi does. Very different than pi. Pi is circumference divided by diameter. I can't explain what E is in that short of a sentence. It would take a couple paragraphs for me to explain where E comes from, and I don't know that this is the right time to discuss it, to be honest with you. So you got to trust me on it that E is just a number, okay? It's just 2.7 something. So what does that ln mean, and why did I just mention E? Because you don't see E anywhere in here, but this ln really means log base E. It's used so much in science and mathematics that they abbreviate this down to ln. Well, you might say, well, it doesn't save you a whole lot of letters. It saves you, what, 2 letters? Because it takes us 1, 2, 3, 4 letters to write this out. It takes 2 letters to write that out. So I don't know. It's not a huge savings, but that's what mathematicians do. So log base E of 7 is equal to x. These are identical. Well, not identical. I mean, they look very different, but they're equal. They're equivalent, these two statements, okay? So what does that mean? Well, if we were able to do this one up here, E or A to the 8th power equals 5, we should be able to do this one down here. I don't mean that in a shaming way. It looks I guess it looks somewhat different. We got E to the x is equal to 7, all right? So this A is kind of like a variable. We don't know what that A is. This E, we know what that is. That's 2.7 something. So I hope I'm making that clear. All right, so what are you going to do next in the next set of problems? You're going to do stuff like this. You're going to evaluate the expression without using a calculator. Well, what does that mean? We should be able to rewrite this guy so that we don't have log base 4 of 1. We have something that makes a little bit more sense, like 4 to some power. I'm going to put like a question mark up here, is equal to 1. That's really what this is saying. What do I have to raise 4 to get 1? Well, if we're going to do that without a calculator, they've got to give us problems that we can kind of think our way through. What would you raise 4 to get 1? I would raise it to the 0 power. So like my question mark up here is equal to 0. Now maybe some people, this would make more sense. Like put 4 to the x is equal to 1. That's really what they're asking. What do I have to raise 4 to get 1? I'd have to raise it to the 0 power. Okay, so your answer is 0. On this one, let's see how we would do this, because like we said, E is, 2.7 something, right? So how in the heck are we supposed to do this without a calculator? Well, this is equivalent to, this statement right here is equivalent to, what would I have to raise E to get the fifth root of E? It doesn't seem to help a whole lot because this side looks very different than this side. Remember, when you're evaluating exponential equations like this, we'd love for the bases to be equivalent. Well, wait a minute. They are equivalent. Both of them are E, and you might say, I don't see how this is an exponent over here. Let's do a little review. The fifth root is the same thing as the 1/5 power. So we get E to what power is equal to E to the 1/5? Well, that question mark has to equal 1/5. All right? I hope I'm making these examples clear. Please try the next bunch of problems in our assignment. Thank you.